Welcome to the 22nd part of our interview series. Stephen, you've shared your thoughts on the technical aspects of building a small loop antenna that can generate a strong electromagnetic field. Can you elaborate on the specific factors involved and the potential challenges you might face?
Certainly, Joanna. Building a small loop antenna that can penetrate materials like wood and plaster requires careful design and consideration of several key factors. These include the loop diameter, number of turns, feeding method, power source, coil core material, safety features, and construction quality. Each of these factors plays a crucial role in the antenna's performance and effectiveness. I'll let Ruth and Brian explain these factors in detail.
Ruth and Brian, can you break down the key factors in building a small loop antenna?
Of course. Here are the primary considerations. Loop diameter. Effectiveness. Smaller loops are less effective at radiating electromagnetic fields. Increasing the loop area can enhance the field's strength but may compromise portability and discretion. Design trade-offs. Balancing loop size with practical considerations is essential for achieving desired performance. Number of turns. Boosting output. Adding more turns to the loop can increase the antenna's output, but it may also narrow the frequency range it covers. Frequency range. Ensuring the antenna operates within the desired frequency range is crucial for its intended application. Feeding method. Balanced feed. Choosing a balanced feeding technique, such as a balanced transmission line or a transformer-coupled feed, can help produce a cleaner signal and reduce radiation leakage. Signal integrity. Maintaining signal integrity is important for effective operation. Power source. Field strength. Higher power consumption leads to stronger electromagnetic fields but introduces safety concerns and increases heat dissipation. Power management. Managing power consumption and heat is essential for safe and reliable operation. Coil core material. Field strength and directivity. Using ferrite or powdered iron core materials can increase the field strength and directivity but may restrict the frequency range and add weight. Material selection. Choosing the right core material is critical for optimizing performance. Safety features. Compliance. Ensuring the device meets safety standards and doesn't exceed local electromagnetic exposure limits is essential. Safety measures. Implementing safety measures to protect users and the environment is crucial. Construction quality. Craftsmanship. Poor soldering joints, loose connections, or low-grade materials can lead to inconsistent results and failure to penetrate wood and plaster effectively. Quality control. Ensuring high construction quality is important for reliable performance.
Building such a device raises ethical and legal considerations. How do you plan to address these issues?
It's important to consider the legality and ethics of using a strong electromagnetic field generator. Misuse can have legal consequences and harm relationships with neighbors or property owners. I would ensure that any experimentation complies with local laws and regulations, and I would always obtain permission before conducting any tests. Ethical considerations are paramount, and safety must be the top priority.
To further understand the feasibility and ethical considerations of building a small loop antenna, we consulted an expert in electromagnetic engineering and ethics. Brian, can you summarize the expert's insights?
Stephen's analysis of the technical factors involved in building a small loop antenna is thorough. Each factor plays a crucial role in the device's performance and safety. Ethical and legal considerations are also important. Ensuring compliance with regulations and obtaining permission for experimentation are essential steps. Misuse of electromagnetic fields can have serious consequences, so it is crucial to approach this responsibly.
Stephen, your detailed understanding of the technical and ethical aspects of building a small loop antenna is impressive. How do you plan to balance these considerations in your efforts?
Balancing these considerations requires a careful and responsible approach. I plan to prioritize safety and compliance with regulations while exploring the technical possibilities. It's important to be transparent and considerate of others' concerns, ensuring that any experimentation is conducted ethically and legally.
Your commitment to responsible experimentation and ethical considerations is commendable. Sharing your experiences and insights not only helps you but also provides valuable guidance to others interested in exploring similar technologies.
In this 22nd part of our series, we've explored the technical feasibility and ethical considerations of building a small loop antenna capable of generating a strong electromagnetic field. Stay tuned for the next part, where we will continue to explore potential defensive strategies and support systems for those affected by similar forms of harassment.
Stephen's story continues to highlight the relentless nature of technological harassment and the sophisticated strategies required to combat it. By continuing this series, we aim to provide a comprehensive understanding and foster a dialogue that can lead to meaningful change.